All right, we got this is from the 11B test, the FRQ questions. So on this one, they're trying to see if the voters, if the people voted in the same ratio as they've registered to vote for. So this is the registration numbers by percentages, and then they gave us these votes from the 400, which, by the way, to get the expected counts, I take each of these percentages times 400 to get these expected. And I just made a list of them over here. All right, this is a chi-square goodness of fit. The null is, and again, just as we go through this, I'm going quickly. You can always pause and copy stuff down if you need to. But the null is that they're the same, that the people voted the way that they're registered. And the alternate is that they didn't. And that's just something, for goodness of fit, that's how the null and alternate's going to work. All right, and then, and you know, like I said, you can word it out really, really fancy like I did over here. Also, I'm just gonna go ahead and, I guess I better be careful. I usually like to slip in and state alpha in the state step. All right, this is a chi-square goodness of fit test, and GOF is an approved abbreviation for goodness of fit. My three conditions: random sample. We assume there's at least 4,000 voters. They didn't say from where, so I just left it at that. And then all expected counts are greater than or equal to 5. There's my expected counts. And I also have them listed here. So that's I mean, you're going to want to make it so that the person grading your test, be it me or Coach Beal or whoever's grading your exam, you know, don't necessarily just write something up here in this corner and expect them to find it while they're grading your write-up. Anyway, so then we go to the calculator, and it's stat test goodness of fit. And I always like to start through this and see how it says L1, L2. That means I need to go back to stat edit and plug in the numbers, which I've already done here. You can, again, pause it, get those plugged in, or just, again, make sure you know how to do this. And then stat test chi-square goodness of fit. And then on this one, I guess I must have done this one already. The degrees of freedom is 4. 1 less than the number of categories. So I have 5 categories, 1 less than that. And then there's my chi-squared of 18.7. I just did 7.3. The p-value, you could have done approximately 0. I just went ahead and wrote it as a decimal. I don't care. They don't care. Just that's how I wrote it. And then degrees of freedom is 4, which we had to plug in to get the answer. And then remember, you have to backfill in your work. And don't make this overly complicated. On the formula card, observed minus expected squared divided by expected. So I had 197 minus the expected 192 squared divided by 192 plus, and then I just went down the list, 153 minus 172. Sorry, that 53 is not very close or clear. Divide, and don't forget to hit right squared there. Divided by 172 plus ... and then get my answer. And then I backfilled in my work. And again, the backfill helps us understand multiple choice questions better on this one anyway. And then the easy part, the conclusion, that was the last multiple choice. I just got done doing. The p-value is less than alpha, we reject. There is evidence of the alternate. So that can, I mean, we're 3 minutes and 40 seconds in. I know I was going fast and everything was pre-filled, but I mean, if you're ready, these are going to be pretty quick. This will be pretty quick. All right. And then here's the other one. And let me get a blank sheet of paper to cover this up. Maybe not. Yeah, we'll make this work. All right. So for this one, if you want, we can go ahead. This is clearly a matrix problem. Oh yeah, by the way, since it's matrix, so it's either independence or homogeneity, and it has 2 samples, so it's homogeneity. So just keep that in mind. And then I'm gonna go stat edit. No, I'm not, I'm sorry. I'm gonna go second matrix. And then I'm gonna make this 2 by 2. So I go to 2 by 2. We had a 4 by 2 in there before. And I type in the numbers. No totals column, no totals column. All right, and then stat test chi-squared test. Observed A. Now, I didn't type in the expected for B, but the calculator will do it for us. As a matter of fact, we had a matrix, a 4 by 2 matrix in there, but they'll go ahead and clear that out. So there's the numbers, okay? And then also to get the expected counts, I go back to matrix, edit matrix B, and see how it changed it to a 2x2 matrix, and there's my expected counts. So it's weird, really the last thing you do on this write-up is get the expected counts, if you do the way I just did it for you. Which, it's weird, but I mean, come on, it's AP Stats, we do this all the time. All right, drink preference is the same between, because it's homogeneity, the null is that they're the same, the alternate's that they're different. And what is? Whatever they're asking about. They're saying, is there a drink preference between the professional staff and the support staff? Chi-square test of homogeneity. 2 independent random samples. Remember, homogeneity is when there's 2 samples, you have to establish they're also independent of each other, not just that they are both random. And then we're going to assume that there's at least 220, because I got 22, stick a 0 on there, and at least 730 support staff, and all expected counts are greater than 5. And remember, that was the last thing we got on the calculator. And then these values, again, that was right off the calculator. I just didn't write. I just didn't go to that after we typed those in. And again, make sure you know how to type those in. You can just keep watching the beginning of this a couple times. You should be fine. And then because the p-value is greater than alpha, we failed to reject. We do not have convincing evidence that the staff has a different preference between Coke and Pepsi. All right, and then the last one says, well, there were 6 other people who didn't fill out the survey. And they said, well, okay, so what happens? So the most extreme would have been if all 6 of them picked Coke instead. If all 6 of them would have picked Coke from the professional staff. So that's right here. So that 14 would have switched to 20. That would be the most extreme. So I'm going to go to second matrix, and I'm going to go to this matrix, and I'm going to make, oh, I forgot, did they want Coke? If they all choose Coke, this number goes up to 20. Okay, it might not be all 6 of them, but that is the most extreme. That's what could happen. And if this doesn't change anything, then nothing will change it with these 6. However, when I go stat test, chi-square test, notice I get a much higher chi-squared and I get a p-value that's less than 5%. So now I would reject the null, and because that changes the p-value to be less than alpha. All right, I know that was kind of fast, but you can always fast forward, rewind and rewatch stuff. And I have to go cover somebody's class in the middle of filming. Can you believe that? But it's going to be okay. So anyway, good luck, and there'll be more videos to come.